Our next speaker is Julia Abelsky. She is a freshman at Northwestern University in Illinois. Some fun facts about her are she started her own community service organization. She's presented her project in 4 different languages, including English, Spanish, Russian, and Turkish. She has met an astronaut before, and her idea to spark change in the world is to empower others to be the change they want to see. So without further ado, Julia.
All right, so I'm going to start out with a few statements. I'm sure we've all heard these many times before. Do your best, try your hardest, and be the best you can be. You don't have to admit it right now, but just think about all the times you've let yourself procrastinate on an assignment or let yourself take the easy way out. I'm not here to say that I've never done it and can't, considering I was up till 2 a.m. last night writing an essay, but today I want to tell you what happened one time when I gave an assignment my 100% effort and the journey that it led me on. Freshman year of high school, I was really busy. I was taking challenging classes and adjusting to the new environment. We were also tasked in science class to develop a year-long research proposal. I saw many of my friends take the easy way out, think of simple projects, but I wanted to think of a project that I'd be proud of later on. I decided that I was going to tackle one of the world's largest problems, water pollution. Although looking back, it might have not been the most sophisticated project, I did from it learn about the fields of math and science beyond the routine memorization of facts and laws that I was doing in school. I learned that I loved asking questions, searching for answers, and creating my own conclusions. I got hooked and continued doing research throughout all 4 years of high school. While exploring the different fields of science, I stumbled upon the field of nanoscience, which studies particles and atoms on a very small molecular level. From that, I realized that humans can't see everything around us with the unaided human eye. We also can't see atoms and molecules with general microscopes found in high schools. So in order to do this research, I knew I would have to reach out to the community and use microscopes like these, multi-million-dollar ones, like the atomic force microscope and the scanning electron microscope, both of which I used in the research that I'm going to tell you about today. This research was incredibly fascinating, and I chose to study the way light moves throughout a material. I wanted to create a new material that would be able to change the way light moves. So, with that, I want each of you to imagine yourself amidst a mind-numbing class or meeting. And just think about how amazing it would be to be able to disappear. Yes, we think that would be amazing, but I'm sure many of you are thinking that's also impossible, and that it's stuck within the realms of science fiction. But research has to start somewhere, so I started by asking questions. Additionally, you can look at history. Several decades ago, we thought that walking on the moon was also impossible. But as we know today, we did it. We accomplished it. So what is stopping us from also getting an invisibility cloak? Harry Potter has one. So why can't we all have one too? So with that, I want each of us to be able to do this someday. So my initial question, how I started this research, was how do humans see? Well, light hits objects, it bounces off of them, and hits our eyes. So with that, I then want to explain the concept of invisibility. Let's think about a flowing river. When there's a flowing river and there's a rock in the river, water is naturally going to go around the rock rather than through the rock. So why can't light, just another force of nature, also be guided around materials rather than hitting them and bouncing off of them? That, I thought, would be the concept for my material. That, in addition to testing 200 complex polymer structures that I knew I would then need to organize. So using this concept and then applying it in the lab, I created this cylinder structure within the polymers. The idea is, when light hits the material, it bounces within the interior walls in this long, narrow tube, and by the time it reaches the bottom, the particles of light have run out of energy and are not able to bounce back and hit the viewer's eye. So, as we learn from the definition of how humans see, if light is going through this tube and does not have the energy to bounce back, hit the viewer's eye, it's then becoming invisible. Yes, I did say invisible, and I was completely shocked when I saw these results. As only a high school student, I was successfully cloaking things in a lab that most people can't enter until they're graduate students in college. I was shocked and so honored to have been given this opportunity. With cloaking, I then looked at cloaking aluminum and gold metal nanocomposites, very, very small particles. I put them in the microscope and then poured my liquid solution with these cylinders and looked to see if I could cloak them. I put them in, did a scan with the microscope, and then they showed up, of course. But when I poured the liquid solution over it and then did another scan, the particles did not come up, showing that I'd successfully changed the way light moves throughout a material, something that had not been done in the 21st century with man-made materials. From this, although very interesting, it extends beyond the field of invisibility, showing that I can maneuver the way light moves. This can be applied to glasses to create more powerful lenses for those that are currently considered blind would be helped by these more powerful lenses called super lenses. Additionally, it can be used to create more accurate sensors for deep sea research and for fishing companies. And lastly, it can be used for ultrasound scans. It can be used to increase the accuracy for medical diagnostics. With this research that I conducted throughout high school, I competed in many science competitions. I competed at school, city, state, national, and international levels. Won 40 different prizes for my work, including an international first and second place finish. Let me be honest. The path to these results was not nearly this simple, was not free of glitches and hitches, and was not this simple. In fact, I mislabeled my solutions several times, and misread my results quite a few times, and started a few fires in the lab. But from all of this, I learned about myself, I learned about perseverance, and I learned how to go around these mistakes. So that, for me, was a huge learning curve, but I really am proud of what I'd done throughout high school. With this research, fictional characters like Harry Potter and Wonder Woman may come join us in the 21st century with their invisibility cloaks. So, let's remember where all of this started. This started with that one required project from freshman year. Just imagine if I'd blown off that assignment. I would not have been able to do this project, would not have gotten experience with cutting-edge research, would not have found my passion, and would not have been standing here today telling you my story. Each of you will have some sort of assignment, project, competition, or interview that, if taken seriously, will lead you to an incredible outcome. Take my word for it and do your best. Put your best foot forward in everything you do, whether you're still visible or invisible. And hopefully someday, I'll be able to make that second option of having an invisibility cloak a reality for all of us. And hopefully soon, we'll see signs like these and sales on these possible in every store near our homes. But before I end this with you thinking I'm a complete nerd and I'm just totally infatuated with invisibility, although that's true, I wanted to share one more aspect of me. I'm on the Northwestern University Division I NCAA varsity fencing team and would not be a true Wildcat if I didn't end this with, go Cats.